Okay, today is learning about volume of pyramids and cones. But first, before we start, I want to talk about Cavalieri's principle. And it's a theorem. It says that if you have two space figures, so two solids, that have the same height and the same cross-sectional area at every level, then they have the same volume. So basically, we have here some cylinders and some rectangular prisms. The cross sections are what are outlined in red, okay, here. And at every point, you have the same cross section, circular for the cylinders and rectangular or square for your rectangular prisms, depending on how you are intersecting that plane, okay. That as you stack these up, if they're the same height and they have the same areas for every cross section, then you're going to have the same volume for each one of these. So on here, I know it's a little hard to see, but you probably can go to mathbits.com. That's where I took the picture from. And this radius is about 3.09, but when you take its area, the area of that comes out to about 30. It's about 29.99. The area of this rectangular cross-section is 6 by 5, so that's 30, and so on and so on. So that means that even if these are at the same height, because the cross-sections are the same area, that two-dimensional cross-section, that means the volume of each one of these, because they're at the same height, will be the same volume. That's what Cavalieri's principle says. Now, it doesn't matter whether or not these are standing straight up, which we call right pyramids, or in this case, it would be right cylinders and prisms, because it also applies for pyramids and cones, or if they're oblique, which means they're leaning. Okay, so that's what this means. So, and you have that in your notes. All right, so let's just look at now specifically for pyramids and cones. This is a right pyramid. Okay, it stands straight up. Its apex or vertex is at the top. The height drops straight down to the center of your base, whether it's a rectangle or if it's a triangle or if it's a square. But here in the oblique rectangle, it seems to lean a bit. So this lateral face would be a little bit larger than this lateral face, but the height is still from the apex down to the base, but not at the center. Okay, and that's all that's depicting. And ditto for cones. Okay, so a right cone, straight up and down. This is its height or altitude. This is its radius. Okay, its slant height is still there, otherwise denoted by L or subcases S, depending on who's writing up the problems, but typically known as L. All right, and then this is an oblique cone, which kind of leans a little bit. All right, so it still has a height or an altitude, okay, from the vertex down to the base, all right? But it's not at the center of the base. It's just how high this thing goes from bottom base all the way up to the top. So that is not the same as what's here, showing you a slanted line here. And so this is not meeting at a right angle as it would in the right cone. Right? And that's still your radius here. This up here is not your radius, okay? All right. All right, so now that preview lesson is over, let's get started and find the volumes of pyramids and cones. And of course, we'll start with a pyramid. All right, first pyramid here, volume of a pyramid, we have a base with edges of 15 and height of 22. So that means these are 15 each, okay? And so write on your pyramid or your cone appropriately. And then in here, to the center, okay, is your height. And that height is 22, okay? So what we need to do for this is to find the base area, capital B, as always is the base area. And instead of memorizing all these different formulas for a square, a rectangle, a circle, a hexagon, which we haven't done, you can just remember the general rule, and you look at that and go, hey, the base happens to be a square in this case, so the base area is going to be 15 by 15. So you use your smarts, your intelligence, to calculate those areas without having to memorize a million different formulas, because there would be plenty depending on what your base will be, okay? So this will come out to 225, and in this case it's inches squared because it is a base area. All right, volume of a pyramid or a cone is 1/3 base area times its height, and the height is this 22. So now we can just put volume equals 1/3. The base area is 225. The height is 22. You take out your handy dandy calculators, and when you are done calculating that, you are going to get 4950 over 3, and right to 1,650 inches cubed, okay? Because what you're doing is you're taking this base area, which is inches squared, and you're taking this length, which is height of inches, and you're really multiplying inches squared by inches, so inches cubed. And that is your answer. It's that simple. All right, now let's get into something that might be a little different. Now that kind of looks like it's an oblique solid, but it's really not. It's a right triangular pyramid. Your base here is a right triangle, okay? It's got a length of 8 and a base of its own of 6, and then this 10 dotted line is the hypotenuse of the base right triangle. Right, so we don't need that. If you were doing surface area or a lateral area, we would need that, but we don't need that 10. It's just there to mess with you. So volume, again, is 1/3 base area times height. Now, base area in this case is of a triangle, okay? I always denote what I'm looking for, and so it's half base height, meaning a lowercase b, just of the triangle. So my triangle is this, 6, 8, and 10. So this base area of my triangle is half of my base of 6, my height of 8, or vice versa. And so your base area of your triangle is going to be, cancel that out, 3, so 24. And that's centimeters squared. All right, so that's your right triangle base. This thing is 12 centimeters high. So your volume is going to be 1/3 of that base area times height. So 1/3 of 24 times the height of 12. Okay, you can cross those out. If you need a calculator, you get it. So your volume is going to be 18 times 12, 96 centimeters, and it's volume, so cubed. Okay. All right, so just take a look at what you have before you jump to conclusions about what, if it's oblique or not. Although it doesn't change the routine, you just have to make sure you have the right information to put in to your formulas. All right, now, what if we're missing a height? Okay. Well, that's not so bad. So the base of the following pyramid is a square. All right, so great. We know it's 8 here, so it's going to be 8 here. The volume is given. It's 240 feet cubed. What is the missing length? All right, so the missing length is height. That's what we're looking for right here. So again, volume is 1/3 of our base area times our height. So let's get our base area, and that's of our square. So it's 8 by 8, so 64 feet squared. Okay? Now, we have the volume in this case. So we're going to just plug in. 240 equals to 1/3 of our base area of 64 times our height. Okay. All right, so what I would do here at this point is I would just multiply each side by 3, because 64 is not divisible by 3. It's going to give you like decimals, and then you could lose accuracy. So just make it easy. Multiply everything by 3 on each side to ditch the fraction. So 240 times 3 is going to give you 720. So your 1/3 is gone. All right, so that's really essentially what we're doing, okay? So then we're just left with 64h. When we divide by 64, h is going to be 1.25. So height is 11.25, and in this case feet, and that's our height. Okay. All right, that's how that works. So having a missing length is not a big deal. You just have to do a little bit of calculation. Just don't forget the proper units. All right, now let's go to cones. All right, cone. An ice cream cone, of which I would love to have some ice cream right now myself. Okay, it's 7 centimeters tall, and it's 4 centimeters in diameter. So we might have to do a little drawing when we have just a template here. So if it's 7 centimeters tall, it's a right cone. It's not oblique. Okay, we're going to bring that down to here, and that's 7 centimeters. And its diameter is 4 centimeters, which means that each side is 2. Okay? All right, so how much ice cream can fit entirely inside the cone? Okay, so our base in this case is a circle. All right, so new formula basically, pi r squared. So base of our circle, or radius is 2, so it's going to be 4 pi altogether because 2 squared is 4. All right, our volume is 1/3 of our base area, which is 4 pi, and I really should put centimeters squared on that. And it times our height. Our height is 7. So our volume is going to be 28/3 pi. That's exact, all right, and that's in centimeters squared. This is exact. Now, if you want to take out your calculator and you multiply 28 times pi, divide by 3, or do 28 divided by 3, and then times that answer by pi, you're going to get approximately, what are we going to get here? 29.3106, and that would be centimeters. Oh, sorry, that's cubed. That's cubed. That's cubed. And we want to find the volume to the nearest whole number. So watch your directions. So we want the nearest whole number. So we're going to now look at this and say, all right, nearest whole number is going to be about 29 centimeters cubed. And that's it. Okay, so again, just watch your units. You could always go back and fix them, but just go back and re-look at them and make sure you have proper units on them. That's an easy change. Okay. And last but not least, what if we're missing a piece? Well, height would be easy enough, and what if we were missing a radius? All right, well, let's see. All right, so we have a volume of cone. It's 200 millimeters cubed. What is the missing radius? All right, so we're looking for this guy right here. Okay, we want to know what it is. All right, right answers in terms of pi, and then round to the nearest 100. Okay, so let's take a look at what this is. All right, again, volume is 1/3 our base area times our height. We have our height right here. Okay, so we need base area. This time it's a circle again, so it's pi r squared. So our base area is going to stay r squared pi if you want, or pi r squared. That's up to you, how you want to write it. We don't have the radius, so we can't do anything with it yet, so we have to leave it this way. So this is going to be important. Okay, now, volume. Volume equals 1/3 of that base area times our height. Our volume is 200, so we're going to substitute in 1/3. Our base area is pi r squared. Okay, I think that's just easier to write and say. And our height is 10. All right? So now what we have to do is divide and isolate our r squared so that we can then use square roots to take the square root of the number that's left on the left-hand side here and get what r is. So again, I would get rid of the fraction because dividing 10 by 3 is going to give you another decimal. So just let's ditch the fraction altogether. Divide everything by 3 on both sides. Doing that is going to give us 600 equals, these will cancel out. That's the whole purpose. Remember, it's multiplication. Any order you multiply by commutative property does not affect the answer. So ditch those. 3/3 is 1. So you're left with 10. I like to put my numbers in front. Pi is a number symbolically, and then r squared. Okay, keeping our variable. So now what I'm going to do is I'm going to divide by 10. You can divide by 10 pi, but if you're doing that in a calculator, you would have to put in 600, your division sign, and parentheses 10 times pi, close parentheses. Otherwise, you will get an incorrect answer. So I like to do it like this if I'm doing it on paper and I'm not sure about how I'm going to divide that, or I could make a mistake. So 600 divided by 10, crossing out your zeros, or just doing division, is going to give me 60 equals pi r squared. All right, now divide by pi. Since they wanted it in terms of pi, you really don't want to do the step of dividing by 10 pi here anyway. And reduce. So you're going to have r squared equals 60/pi. All right, so we're not done yet. I'm going to bring this up here. So if I take the square root of both sides, okay, then I only want the positive r because I want it's a length, a distance. So I've got r equals the square root of 60/pi, and the units are millimeters. And that is exact. It's kind of weird looking, but it is exact. Now, if you take this and put it in your calculator, you would take 60/pi and then take the square root of it. Old calculators, you do it in that order. If you have a new, more graphing calculator, take the square root symbol, get your fraction button, all right, and then put 60 over pi, all right, and then when you do the division, you're going to come out with pi, r is approximately equal to 4.3702, and r is approximately 4.37 if you're rounding to the nearest hundredth, and it's in millimeters. And you are done. All right, so use your calculator carefully as you're calculating these. A lot of this can't be done in your head. Just jot it down, write it down in your notebooks, and you should be all set. Any questions? You know how to reach me.